This talk is called What Your JavaScript Does When You're Not Around. And I've worked with JavaScript for a long time. Whenever I say that title, I like to take a minute to picture what my JavaScript is doing right now. And I always know that it's some stupid bullshit like this. This is just classic JavaScript. Anyway, I can make fun of JavaScript because I love it. My name is Emily Nakashima. I lead the dashboard engineering team at Bugsnag. Bugsnag does exception monitoring for JavaScript, but we also do mobile apps and about a dozen different backend languages and frameworks. So all of your errors monitored all in one place. Before I was at Bugsnag, I worked at some other great companies. I really like blue logos, apparently. And in the past, I've done full stack development, and I've even been on the pager rotation a few times. I'm sorry to anyone else who was on it with me or in my escalation path. But my jam is really browser JavaScript and browser monitoring, especially the kind of work that some companies have started calling front-end infrastructure. And I want to talk to you about a funny thing that I have watched happen in the past maybe 3 to 5 years. Kind of at the exact moment that most of my backend developer friends were figuring out how to get really good visibility into what their applications were doing in production, all of my front-end developer friends were very busy taking all of that application logic and moving it off of the server and into JavaScript land. Of course, these are a big part of what I'm talking about. So single-page app frameworks, like especially React, but all these other ones too, are helping developers build the newest generation of kind of complex and app-like browser UIs. And I think even if you're not using one of these frameworks, there's a very high likelihood that you are writing and deploying your most complicated JavaScript ever, kind of right at this moment. And of course, this concerns me. By moving more of our application logic to the browser, we have invented kind of all of these new ways that we can kind of leave our users staring at a blank or broken page when something goes wrong. And I think at most companies that I know of, if you're not like one of the really big companies who's doing a great job of this, these kinds of issues won't trigger anyone getting paged like a backend problem would. So I want to tell you the story of how we deployed our new JavaScript application to production, and I kind of want to talk through all of the weird stuff that we saw and talk about the process of getting better visibility. So this is a project we call Dashboard 2. Before Dashboard 2, there was a project that was called, that's right, Dashboard 1. Very predictable. This was released in 2013, and it did a really nice job of kind of showing errors and metadata about errors and letting you answer really basic questions like, which error happened most often this week, or was there a new error that started happening this week that we care about? But if you wanted to kind of ask a more complicated question, like, I launched a new version of my Android app, is a particular error happening to more or fewer users in the current release or the past 2 releases? All of a sudden, if you try to do that kind of more complicated analysis, it was a lot harder. So we made a bunch of architectural changes to our backend infrastructure, and we added Elasticsearch and a bunch of additional services to facilitate that. And the goal of all of this was to enable like in-depth filtering and kind of better visualizations for customers. And then, of course, we had to build a new UI to let people take advantage of this. So this is the UI that we were working on that would become part of Dashboard 2. And of course, this is where I come in as kind of a front-end person. I joined about 3/4 of the way through this project, which is, as you can guess, a really fun and exciting time to join a big bang rewrite. We were making all these big changes to our existing technologies. We were switching to using React and Reflux in the browser, and we were doing a total rewrite of our Rails API too. And of course, there were no front-end tests and kind of limited back-end tests because we were sort of still figuring out what we wanted the product to do. So that was really fun for a new contributor, very exciting. And I think all in with all of our front-end and back-end changes, we were probably deploying about 40,000 lines of new code to production. And of course, like having just joined, I've only read like maybe a few thousand lines of code that we're deploying. I don't even actually know what all the features are that we're shipping at this point. But there's no time to worry about that. We're going to go for it. So one day we just take this giant branch, we merge to master, and we just do a big bang deploy. And then, of course, what I have to do is go jump in and look at our monitoring to try and figure out exactly what we just shipped out to production. So it's worth saying a little bit about what's kind of in our front-end monitoring toolkit. We have basically 2 different things. We measure performance, so we use Datadog to track metrics. And we have this set up in our backend infrastructure, but it's also possible for us to beacon timings from the front end, send them to the app server, and then send those to Datadog. We also use Google Analytics, since we had that on the site at the time, and it just collects navigation timing, so like kind of page load timing data by default. And then we also measure exceptions. There are a handful of great vendor products in this space right now. We use Bugsnag for reasons that are pretty obvious, but they have at the core functionality is pretty similar, and I think any of the kind of vendor products do a decent job with everything I'm going to talk about up here. So they all kind of work the same way. They have just a little piece of JavaScript that listens for uncaught exceptions in the browser, and then when an exception happens, it's going to beacon that exception and all of its associated stack trace and metadata back to the server to display it in a dashboard, maybe alert on it, send it to integrations, that kind of thing. You could also potentially roll your own system like this, although I'm up here to tell you, don't try to roll your own. It just sort of takes more or less work depending on what you pick. And those are kind of the two items in our toolbox. I'm not going to talk too much about our front-end performance metrics. I think there are a lot of really good drop-in libraries like Boomerang and lots of vendor tools in this space that will collect these for you. And also, I think our stats here were really not that interesting. Our JavaScript and CSS got a little bit larger because we wrote this big front-end app. So of course, our page load times went up a little bit. We're also a fairly small company. Even though we process a lot of data, we don't have massive user traffic actually looking at the dashboard. So our front-end page load stats are pretty volatile, and it can be a little tricky to derive useful data from them unless something really big has changed and gone wrong. The browser exception monitoring side of this is a totally different story. I think even if you have low traffic, you get a lot of actionable data here. And of course, we got a ton of exceptions to look at. Some of it was helpful, some of it was unexpected and kind of hard to parse. So I want to talk through some of the most surprising cases that we saw, because I think they kind of illuminate some of the bigger issues in trying to do browser monitoring well. So there's definitely some stuff that comes in that just makes complete sense. Here's a really good example. We deployed a small change to a graph on the site, and then we start seeing this error right away. So the error is reference error. This .draw timeline is undefined. The stack trace points back to one of our own JavaScript components. And this is the kind of error that I love, because it's super easy to dig into, right? There's a function that has a unique name. It's in our own code. We can just sort of go update the reference to this and fix whatever broke when we were kind of changing stuff around and someone wasn't being too careful. But of course, everywhere I've worked, only about 20% of the errors we see fall into this category. The rest are usually a lot harder to make sense of. Most of the time, you see stuff like this. So this error is NS error XPC security manager veto. What does that mean? I have no idea. I'm just going to go Google it and try and find out. It's not coming from any of our files. The stack trace doesn't say any particular file that I've heard of. It's from something called top level. So of course, you go and Google it, you find out. This is a bunch of people on forums talking about how their Firefox extension they're trying to build is broken, and it's just sort of throwing this error in a loop. OK, now we know. Our code is fine. Someone has just installed this terrible browser extension, and something is totally broken. And it's throwing this error every time a user visits our website. We filter out, like Bugsnag, the product filters out most browser extension errors by default, but there are a few like this that are hard to catch. If you're rolling your own, you'll probably spend a lot of time trying to filter out browser extension errors like this. At GitHub, we used to roll our own, and we would add a line of code at a point of collection each time we found a new browser extension stack trace type to filter out. And it was basically like we had 200 lines of special cases to filter out. And without that, it was kind of more than half of our errors that would come in every day were from extensions. And we really want to filter those out because they're not actionable. There's no way to tune them out. In the good products now, there's just kind of a button that lets you ignore those. So in Bugsnag, it's just called the ignore button. But we definitely want to make heavy use of that so that we can kind of keep our data actionable. So number one, what is my JavaScript doing when I'm not around? It's hanging out in a noisy room. We just switched this year from using Gulp to using Webpack to kind of package up all of our JavaScript and CSS into 3 small files. And I think it's really easy for us to kind of start telling ourselves that that's the only thing that's running in the browser, but our monitoring is constantly telling us that that's not true. For one more example, here's an error we suddenly saw spiking out of nowhere one day. The exception class is just error, always a favorite, very descriptive. And the message is, cannot find module bind all, and it's coming from some third-party CDN. So of course, this is an analytics vendor that we work with. And they just push bad code to production, and they're experiencing what is effectively an outage. Their infrastructure is probably fine, but they've deployed this code that's going to throw an error in the client of every single customer. So the cool thing is we actually found out about that a few minutes before it even went up on their status page, before they were scrambling to fix it, because we get a Slack notification whenever there's a new error on our site. We could have taken action right away if we'd needed to, and potentially fixed this even before the vendor had come up with a fix. We investigated it. We found out it wasn't breaking anything. We didn't need to do anything. But it was definitely a wake-up call to us to kind of investigate some of the callbacks we had and make sure that they didn't assume that third-party code would always be there. This kind of seems like a weird one-time problem, but once you start looking, you'll realize that these issues are kind of happening constantly. And it's really hard to overestimate the magnitude of this third-party code problem on some sites. If you have like any kind of advertising or remarketing tag on your site, a lot of those can load other scripts. Sometimes they'll load different scripts for different users, depending on where those users have gone in the past. So this is a graphic that I love because I feel like it really drives home how big this problem is. This is from Ghostery. They have an enterprise product that will let you kind of get this data for your own site if you're curious. But this is a report for TMZ.com, and it's all the third-party code and tags that can load on their site. So the nodes out on kind of the far right of that picture are tags that have been loaded by tags that have been loaded by other tags. And when they counted it all up, they found out that there's 539 possible tags that can be loaded from 68 different unique vendors. All of those could potentially be running in the client with your client-side code. They also all have access to your client-side data, which horrifies me, but that's a different talk. And anyway, if you allow all these third parties on your site, all this code, it's obviously running with your code, it's sharing the same global scope, there's a lot of space for things to go wrong. TMZ is a bit of an extreme case, but I've definitely worked at e-commerce sites or looked at media sites that are not that far off from this. I think the one thing that we've done here that has been the most helpful for us to mitigate this problem is the migration to Webpack, which automatically kind of moves all of our code out of the global scope. So everything is running on an anonymous function, and it means that we have to be more explicit about referencing external globals, so we're a little sheltered from the fallout from this kind of stuff. But it can still cause problems here and there. And of course, the flip side of that is a large number of our users have ad blockers installed to kind of get away from that mess on the previous slide. So that's no surprise. Like we have a lot of developers, of course, they're going to install those. But sometimes they block things that you wouldn't think of as ad scripts. Pretty much any third party, including analytics providers, including exception monitoring, any other kind of third-party script can be blocked at any time. So it was a lesson to us to not assume that everything happening in the browser is being reported. The best way to try and mitigate that is to be reporting back to your own domain from a script that is loaded from your domain. But we have to just sort of assume that we're not working with 100% of the data. And number two, we have to assume that our code doesn't always run where we think it runs. It has a tendency to wander off to one place or another in ways that you wouldn't expect necessarily until you start thinking about it. So we deploy our code to app.bugsnag.com, which is our kind of primary dashboard domain. We also have like a self-hosted offering, but we'll talk about that. And of course, that points to some Google servers in the cloud. And we kind of can tell ourselves that our code is always going to run at app.bugsnag.com when it's in production. But when we would look at our monitoring, we would find over and over again that we'd see other domains pop up. And that was an interesting one for me. What we found out is that most of the time they're proxy sites. One of the most common proxy sites out there is, of course, Google Translate. So Google can serve your own code on the translate.google.com domain. So this is our marketing site translated into Portuguese. That's cool. That's a legitimate use case for us. We definitely want foreign language customers to be able to check out the product and use the site. And of course, there are also proxy sites that have a valuable function of helping people get around kind of political firewalls. So if you're a content site, you may want to think about being able to support those. One notable one is GreatFire. And they have a couple of projects that help users get around Great Firewall restrictions by mirroring blocked political content or news sites. So depending on what kind of information you're hosting on your site, it might be really important to you to kind of support those kinds of use cases. For the most part, you don't have to do too much. The proxies usually will handle rewriting all the headers and rewriting URLs in the page. The one thing that was a good reminder for us was don't write JavaScript where we check the host name to try and figure out if you're in production or not. We should actually just put a meta tag in the page that says the actual environment and check that. And of course, on the flip side, if you don't want to support these proxy sites, if you're worried about someone kind of ripping off your UI, which that happened to us, someone created bugsgan.com, so that was cool. It's an exciting day. You can actually look at the domain and then throw an error if it doesn't match up to what you expect it to match up to. We've also found that sometimes that developers will see the cool graphs on our site and copy down all the code and kind of start fiddling around with it in the browser. And if they have the same JS, it'll throw errors to us too, so we can kind of see who's playing around with our code locally, which is pretty funny. 3, we've noticed that network problems are happening constantly, a lot more than we think about them happening. Sometimes our JavaScript just doesn't show up at all. We know from our stats that we have lots of customers who are on airplane Wi-Fi or on a slow DSL connection or somewhere far away like New Zealand. and we know that they're having a really different experience than we are in the office. This is particularly important now that we're starting to use a JS framework like React. A lot of these single-page app frameworks will make it really easy to have complex series of request dependencies if you don't look kind of carefully at your code to make sure that's not happening. So all of the gold boxes in this slide are UI components that could trigger a network request for data. And of course, in React, it's really common to nest components inside of other components. So if you're not careful, it's really easy to kind of create these sequential series of requests as you kind of like draw each smaller component of the UI, which is bad. Don't do that. For us, we don't really have enough people to spend a lot of time at the network level to try and make our network traffic faster. But we can do two things. One, we can try to get rid of those request series that we talked about, but we also just want really good visibility into how often people are having network problems on the site. So for example, we saw a bunch of these. Reference error, jQuery is not defined. It happened sporadically. It kind of happened to all different users. We couldn't really see a pattern to it. And of course, when you look through our code, it was really clear what was happening. We have this first script, which kind of synchronously loads jQuery and some other frameworks. And then the second script, when that one runs, if it throws that jQuery is not defined error, you know that first script just timed out. So it was clear that the network request just failed or something else went wrong. So now we know what's going wrong. But we also know that every time teammates look at that error, it'll take them a second to figure out what's going on. So we just kind of replaced that with a check that throws a warning and says, like, warning, jQuery failed to load, just so that our teammates have a little more visibility into what the problem is when they kind of look and see something in Bugsnag like that. There's not a whole lot we can do if a whole file just doesn't show up, if someone is just on a really bad internet connection. If we had more time and more people, we could set up Service Worker in the browser so that we could do offline support and have kind of really fine-grained cache control. But for a small team like us, we just want to try and be smarter about when we make data requests and kind of try and move them earlier in the page load process. We're also getting a lot better about trying to use network simulation tools to kind of look at failure states and slow request states. So we're lucky enough to live in a great time for browser dev tools. Chrome actually has this built in now. You can kind of test out 3G, DSL connections, different kinds of slow connections, or just like simulate being offline, and kind of look at what all the different failure states are that can happen. And you can get familiar with the error messages you'll see so that you can kind of immediately trace that back to a network issue. If you don't want to use Chrome, there's also like standalone tools like Jarl's Proxy that will do the same thing. And finally, we found out that our app is not always used exactly the way we think it's used. Here's a fun one that we saw in our errors the other day. The exception class is waking up dev. And the imp emoji is definitely not a custom error message we have in our code base. Yeah, you guessed exactly what's happening here. This is a developer who's trolling us. Developers tend to run a lot of code from the browser DevTools console. And this is especially true when they are trying out a new tool or a new platform. So a lot of developers will start testing out Bugsnag, and then they'll just sort of start running code in the console, and then they'll realize that they can send us errors from the console, and then they will send us funny things like this. One time I saw someone trying to traverse the DOM to get to a text node that was in there, and we had a kind of an area where there were API keys in our UI, but we had accidentally disabled the CSS that made it possible to text select those. So watching this person kind of try to console hack to that little piece of DOM, it made me realize that we had broken this so that you couldn't copy paste the API key. It was really frustrating, and then I could just sort of go in and fix that before someone had to like write into support and tell us about it. Of course, you know, if you have lots of developers as customers, you'll start to get to know that telltale browser DevTools stack trace really well. The Chrome one has anonymous, and then it has injected script, but they all kind of have their own pattern. So once you start to see it, you'll remember it each time. In particular, we learn a lot from watching people try to hack us. But this is just a subset of the accounts on the site that have XSS in the name. Yeah, very sneaky. The great part is that developers who are trying to XSS us will almost always throw a bunch of errors as they're kind of trying to hack around the site and put stuff in. So it's been fun for us to kind of keep an eye on these accounts and make sure that we're kind of thinking about the same security cases that they are as they kind of poke around the site and throw a lot of errors. So that was a dive into some of the funniest things we saw in our exception monitoring after our big rollout. From there, from kind of looking at all these weird things, we knew enough to start kind of adding our own custom front-end metrics. So I said we had these two tools, the performance and the exception tool. Turns out it's really easy to push custom data to both of those. And the calls to do that look pretty similar. So the first one is just a stats call to push kind of an arbitrary metric to our stats setup. And the bottom one is a way to push an arbitrary event to Bugsnag. So as we started doing this with more and more kinds of data, we kind of stopped thinking of them as a performance tool and an errors tool, and we just think of them as a metrics tool and an events tool. Anything we primarily want to see as a time series graph or a count or gauge, we send to Datadog or Google Analytics or StatsD. And anything we want to look at individually with metadata, like if we want to know the specific user, we send to Bugsnag. We find that there's a lot of things that aren't strictly errors, but still tell us about a problem case. So we set the level property on every event now as either error, warning, or info, so that we don't just look at Bugsnag and assume that everything in there is an error. So one interesting use case for this is a lot of people have the experience with single-page apps that they don't trust the data that's in there. They've kind of been clicking around through a series of complex flows, and all of a sudden the UI looks kind of weird, or you click a button and it doesn't do what you expect it to do. And so we've all kind of learned to try and fix these like crappy JavaScript apps by refreshing the page. So we wanted to see if people were doing this in our app and understand if there were circumstances where people didn't trust the data that was displayed on screen and they choose to refresh. So we started doing refresh tracking. Christian, a JavaScript developer on my team, wired this up. I think it's really neat. Whenever someone presses either Command-R or Control-R, we log that as an event with level info. And then we can look at the pages where users are most likely to not trust our site and try and get a sense for where the places are where the users don't trust the data we're showing them. Not super surprisingly, it was the 2 pages that have our 2 most complicated graphs. And we know it's partly just because those don't auto-refresh. They don't live update. So it's users sometimes just refreshing to get new data. But one that we saw was kind of surprising, because it's not actually one of the most popular pages of our site, is this page, which is the list that shows the collaborators on your account. And we think that the use case here is that people are adding teammates, and they want to see if their teammate successfully got in and was able to use Bugsnag, probably because they want to assign them an error to go look at. And so this was a good lesson to us to maybe think about adding live updates or alerts or something like this to this page. Another related and super interesting use case that I've heard of from other teams using is tracking something called rage clicks. So sometimes you get frustrated and you can't figure out how to get an app to do what you want it to do, and you just sort of start randomly like double or triple clicking things in the UI. So this was something that I heard about from Philip Tellis and Nick Jansma at Sosta. We talked about it at last year's Velocity. So whenever someone clicks a UI element more than 2 or 3 times in rapid succession, they'll record that as an event, and then they can look later and try and figure out. And of course, if you're using a tool like Bugsnag, then you can figure out what page they were viewing. You know if there were any JavaScript errors that happened on the page, and then you also get a list of events that happened before that rage click sequence, so you can try to figure out what aspect of your UI was so frustrating. It's a really interesting data point if you are kind of still working out your UI design patterns, or if you're worried that a part of your UI is potentially too confusing for your users to make sense of. Whenever I start thinking about this, I always think of so much more things that we could track that we just haven't gotten around to instrumenting yet. Pretty much anything that you can check with JavaScript in the browser, you can collect data about. So some possibilities are geographical location. A lot of Run products give this to you out of the box, but you could potentially use your own IP address mapping library to figure out where your users are. You can start monitoring memory usage. You can do DOM checks for conditions create accessibility problems. And you can track push state notifications, installed fonts, screen dimensions, browser languages, online and offline status, battery level and charging status, emoji support if you want to know if your users have the emoji you want to use, page visibility, including whether the tab is in the foreground or the background, connection type, that's a future API, or you can use a vendor tool to kind of try and figure it out. And then you can also look at support for emerging browser APIs. So if you want to know, can I use this particular API, you can kind of start tracking how many of your users have it enabled, and then once it gets up to 98% or whatever, then you can start using that API in the browser. All of these are super interesting and kind of can help you figure out what you can build next in your app. So that was a lot of browser monitoring. After having gone through that whole journey, like what does it all mean? Like what do we want to take away from that? For one, I think it made me feel like browser monitoring is really ready now. Like there isn't a better time. I feel like a lot of people tell me like, I don't know, like if I'm going to actually instrument stuff and get actionable data. I think that the products we have out there now, both on the performance side, the exception side, are super easy to get started with, super easy to use. And I think especially if you're using a complicated single-page app framework like React or Ember or Angular, the payoff is really there. And you definitely want to be instrumenting performance, exceptions, and security, and other aspects of the user experience as you think about them. The corollary to having all that monitoring is that I think front-end developers should get paged. Like, you don't necessarily have to put them on their own PagerDuty rotation, because that probably will feel very strange and foreign to them. But there are definitely channels where, as a front-end developer, you want to be getting pushed alerts about your code if it does something unexpected. Chat is my favorite place for these. Like, so we have all of our new errors go into Slack, and then you can set up highlight words. So whenever there's something that is severity error, I immediately can kind of get a push notification for that. And I think front-end developers should be getting alerts whenever there's a spike in browser JavaScript errors that's happening to multiple users at once, and whenever front-end timings are going up but back-end timings aren't. And I think, if your company works in sort of a DevOps-y way, people will be really excited about this. There's something that just feels really nice and really fair about having your whole team have to work with alerts and be on the hook to respond to production issues. And I think it really does wonders to help your team kind of develop empathy for people who are on the pager rotation and kind of help them figure out how to better write production-ready software. I also think testing everything everywhere is dead. Especially trying to test in every single browser version. A lot of browsers now roll out a new version every few months, and they're getting better and better about building them to spec. And there are just too many browsers for our team to run tests in. So the great thing about this is that it means you can give up the dream of fixing those terrible Selenium tests that are always read in 2 or 3 browsers. Especially for single-page apps, you can actually create these really complex state machines in the browser. So you can be basically, because you don't get a state reset every time you refresh the page, there's all these more complex states, and so trying to test them all in all the browsers would just be like an infinite problem. We still do unit tests. We still want multi-browser tests for our notifier library, but we don't need them for everything. So it's nice to be able to make these tests just go back to being one tool in our tool belt instead of like the one thing that's standing between us and our customers dealing with a broken experience. Another thing that we kind of figured out is that the people who kind of own the monitoring usually don't know what the JavaScript does. There's usually a team that is responsible for the monitoring, and they are usually far away from the JS team. And I think a lot of times they're still expecting that if the site is broken somehow, there's going to be a big spike in 500 statuses, and they're going to be able to go know about that from their existing tools. So it's probably worth sitting down with that team and trying to make sure that they understand what the JavaScript failure cases that could happen look like, and they think that you're also monitoring the right things so that everyone feels like they have visibility. I also think the best tool is the tool your team will use. There's a lot of stats that we could track with Datadog or Web Analytics that we choose to send to Bugsnag instead because Bugsnag is good enough at graphing them, and it's a place that our developers are looking all the time. We definitely could send them to a product analytics tool, and it would be nicer to just kind of slice and dice them up. But I've never been on a team where more than 10% of the engineers look at Web Analytics regularly. So this was a better way for us to get notified of what's actually happening on the site and make sure everyone's in the loop. I think all of this is particularly relevant now that the pendulum is kind of swinging back from native apps to web apps. People are kind of talking about progressive web apps. And I think to kind of make that reality happen, we have to kind of be better than mobile apps. So even with longer release cycles, mobile app developers have been much better than front-end developers at using monitoring to kind of find and fix errors quickly because they get crash reports and look at those. And I think if we really want people to continue to take browser applications seriously as an alternative to native apps, and I think we do, we have to really reach that same level of reliability, and I know that browser monitoring is a huge part of how we'll get there. All right, that's it. Thank you. If you want to talk to me more about browser monitoring, please come talk to me. I'm super excited about it, and a lot of people don't care, so I'm fine with it.